Grid search. Grid search in machine learning. AI intermediate level. Introduction. Machine learning models often have hyperparameters that control how the model learns from data. Choosing the right hyperparameter values can significantly improve model performance. However, finding the best combination of hyperparameters can be difficult because there may be many possible values. To solve this problem, machine learning uses a technique called grid search. Grid search systematically tests multiple hyperparameter combinations and identifies the configuration that produces the best model performance. Grid search is widely used in applications such as fraud detection systems, recommendation engines, medical diagnosis models, customer behavior prediction, financial forecasting. Understanding grid search helps learners perform effective hyperparameter tuning in machine learning models. What is grid search? Grid search is a hyperparameter tuning technique that evaluates every possible combination of hyperparameter values in a predefined search space. In simple words, grid search equals testing all combinations of hyperparameters to find the best model configuration. Example concept. Hyperparameter grid means test every combination means select best model. The model is trained and evaluated for each combination, and the best performing set of hyperparameters is selected. Why grid search is important? Many machine learning algorithms depend heavily on hyperparameter values. If hyperparameters are poorly chosen, the model may perform poorly. Example concept. Default hyperparameters means suboptimal model performance. Grid search helps find optimal hyperparameter values, improve model accuracy, reduce prediction error, improve model generalization. By testing multiple combinations, grid search helps identify the best model configuration. How grid search works. Grid search works by defining a grid of hyperparameter values and evaluating all combinations. Example parameter grid. Learning rate tree depth 0.013, 0.015, 0.13, 0.15. Example concept. Parameter grid means multiple combinations means train model for each. For each combination, train the model. Evaluate model performance. Record results. Finally, the best performing combination is selected. Example grid search process. A simplified process looks like this. Define hyperparameter grid. Down pointing arrow. Train model with each combination. Down pointing arrow. Evaluate performance. Down pointing arrow. Select best hyperparameters. This ensures the model uses the most effective settings. Grid search with cross-validation. Grid search is often combined with cross-validation. Cross-validation splits the dataset into multiple training and validation sets. Example concept. Parameter combination means cross-validation means average performance. This ensures the selected hyperparameters perform well on different data splits. A common method is k-fold cross-validation. Advantages of grid search. Grid search offers several advantages. Advantages include systematic hyperparameter exploration, reliable model optimization, easy to implement, works with many machine learning algorithms. Example concept. Complete parameter search means optimal configuration. Because it evaluates all combinations, grid search often finds the best possible hyperparameters. Limitations of grid search. Despite its benefits, grid search has some limitations. Limitations include computationally expensive, slow for large parameter spaces, may test unnecessary combinations. Example concept. Large parameter grid means increased computation time. For very large parameter spaces, random search may be more efficient. Grid search versus random search. Both techniques are used for hyperparameter tuning. Method approach. Grid search tests all combinations. Random search tests random combinations. Example concept. Grid search means systematic. Random search means probabilistic. Random search can often find good results faster when the search space is large. Grid search workflow. A typical grid search workflow looks like this. Train initial model. Down pointing arrow. Define hyperparameter grid. Down pointing arrow. Apply grid search. Down pointing arrow. Use cross-validation. Down pointing arrow. Select best parameters. Down pointing arrow. Train final model. This workflow improves model performance. Example Python code. Grid search can be implemented using scikit-learn. Import grid search CV. From sklearn. Model_selection import grid search CV. Define parameter grid. Param_grid equals max_depth 3, 5, 7. N_estimators 100, 200. Closing curly bracket. Run grid search. Grid equals grid search CV. Model. Param_grid. CV equals 5. Grid.fit. X_train. Y_train. Retrieve best parameters. Grid. Best_params_. These tools automate hyperparameter optimization. Real-world applications. Grid search is widely used in machine learning projects. Finance. Optimizing fraud detection models. Healthcare. Improving disease prediction accuracy. E-commerce. Optimizing recommendation systems. Marketing. Improving customer segmentation models. Autonomous systems. Optimizing perception models in robotics. Concepts learned from grid search. Understanding grid search helps learners understand. Checkmark how hyperparameter tuning works. Checkmark how multiple model configurations are evaluated. Checkmark how cross-validation improves evaluation reliability. Checkmark how machine learning models are optimized. Checkmark how model performance is improved through systematic testing. Grid search is a powerful tool in machine learning model optimization. Simple definition. Grid search. A hyperparameter tuning technique that systematically tests all possible combinations of hyperparameter values to find the best performing machine learning model. Final summary. Grid search is an important hyperparameter tuning method used in machine learning. By defining a grid of hyperparameter values and evaluating all possible combinations, grid search helps identify the optimal model configuration. When combined with cross-validation, it ensures reliable performance evaluation across multiple data splits. Although computationally expensive for large parameter spaces, grid search remains a widely used technique for improving machine learning models. Understanding grid search is essential for mastering model optimization and hyperparameter tuning. In machine learning,